let us begin. So yeah, we are done with Scratch. We're going to learn a brand new programming language. It's called Python. It is, at a lot of schools, the very first language that you learn. And so it's a very common one to know. Applies to many fields, not just to computer science. A lot of other majors have their students take a Python class because it's so prevalent these days to do programming. People like to pick Python. So yeah, without any further ado, let's get Python working. So it is a programming language, and it is not accessible really in a website. You have it on your computer, and then you run programs within the Python that you have installed. So let's go and download Python. You are able to install things on this computer if you would like to work on these computers. You have those rights. So please go to python.org/downloads. Just search Google for download Python download. It will take you to that first, python.org/downloads. And you want the latest version. It's just this yellow one, whatever it says first. That's the one you want. Python 3.11.5, let's say. And so we'll download that and install it. Open. Install now. Yes, I agree. And then, yeah, try to get it installed on your computer. If you have a Mac, it should be very similar. It'll just go to your applications folder. But this is what we want. We would like to install Python on whatever computer we want to use, either the one we brought or the one sitting in front of us, because that is where we will work today. And let me know if you're having any trouble. Did we all find the download link? Sweet. And this was probably going to take much faster on your computer, because it's beefier. On my slow little laptop, it's going to take a second, it seems. It's thinking about finishing. But once this is finished, it will put in the start menu something called Python that we can go and open. Setup was successful, yay, so I can close this out, go back, and we are ready. If one day, like, you're on the road and you're working with, like, your friend's computer, you don't know their administrator password, there are some websites online that you could run Python in. It's just very slow for the thing that we're eventually going to want to do with Python, so I encourage you to just download it on your computer. It's much better. It's not like Scratch. It's a program. It's a programming language that you install. So yeah, if we're good, let me know if you're having any trouble, and I'll come and help you. But I will assume that we are happy. And once it's installed, you can just legitimately search your start menu for Python. And you don't want to click Python, surprisingly. Don't click Python 3.11 64-bit, because that opens up this little terminal-like thing. That is not what we want. That is too low level. Instead, when you search for Python, it's really this idle program that you want. So honestly, you could just search for that. It's idle that you would like to open. Okay? Idle. All caps. And that's a much more user-friendly version of Python, right? So that's what we're going to be working in. Let me know if you're having any trouble finding this window. It's idle shell, apparently, is what it's called. But we want to open up idle, not Python. Idle. All right. Any questions about anything so far? We're all able to get there. It's installing still. So, yeah, what this is, what this is right here is a window into Python. It's a little place where you can write some short Python programs line by line. So Python is a text-based language, and you give it text, and it runs it for you. And this is not really a Python program. It's called the REPL. Okay, REPL stands for Read, Evaluate, Print, Loop. So that's way too small. So what just opened for us right now is called the REPL. It's the Read, Evaluate, Print, Loop, aptly named. And what it's going to do is it's going to run individual lines of Python code one at a time for us. You can enter a line-by-line kind of thing. It's not really a Python program, but if you want to do some quick stuff, it works just fine. So we're going to get there in a second. Let's see. But until, that'll be a couple slides from now. So first I should just explain what in the world is this thing. It's not Scratch anymore, that's for sure, right? But it is a programming language like Scratch. It's just not graphical. So instead of like blocks, code isn't blocks, it's text. Like instead of doing something like this, block number 1, you're attaching that to block number 2, and they happen in order. Just like that, you write lines of Python code. You write line 1, you hit enter, and then you start typing line 2 that does the same thing, and it's going to execute in top to bottom order. That's how Python's going to work. All right. If you want 2 things to happen sequentially, you just put those lines one after the other. All right. That's how that's going to work. And then there's like, that we're eventually going to figure out how to do like an if-else kind of thing in Python. How do we shove that into there? How do we do that with text? That'll be weird. It'll be indentation eventually. That's where we're going. So yeah, every line of Python that is correct has a special meaning. It knows what it's special Python stuff, and it knows what to do. Though because it is text, I can finally say this word, valid. It's impossible to make an invalid Scratch program. It's gonna run. You just drag blocks. You can't like make half a block or something. You can't hack it to make it not work. It's always gonna do something. Python though, you can speak it wrong because like you misspell something. That's totally a possibility. And so a lot of new errors are possible now. And the Python language, it's called the interpreter. It's like somebody sitting looking at your text and trying to convert it to CPU instructions. It's going to yell at you if you make any mistakes. And so I'll show you some mistakes soon. Yeah, that's Python. It's lines of code, textual stuff. So, okay, without any further ado, here are some very simple things that you can do in the REPL. It's a read, evaluate, print loop, and Python knows math. So it's like 2 plus 2. If you hit enter, it's going to read what you just typed. It's going to evaluate it. It's going to print the answer. And then it's going to loop. It gives you another little prompt to do some more Python code. So math is technically valid Python. 2 plus 2. Multiplication is a star, so like 2 times 3. And you can put the numbers next to each other, like 4 times 5. No spacing is necessary. Just hit enter, and it's like, all right, it read this. It figures out what you wanted. It evaluates it, and it prints the answer. That's what the REPL means. All right. Slash for division, like, I don't know, 5/2, 2.5, sure. Remember that remainder operation that I used a percent sign for? The reason I said percent sign in class when I taught you base conversion is because this modulus operator, or modulo operator, is really a percent sign in Python. What that does is you give it 2 things. It's like you give it something on one side and something on the other side, and it divides x by y and gives you the remainder. Remainder after dividing x by y. So that's what that does. So like, I don't know, 42 mod 2, divide 42 by 2, give me the remainder. There's 0 remainder. There's nothing left over. I hope makes sense. So 0. 43 mod 2, though, divide 43 by 2, give me the remainder. There's 1 left over. So you could have used Python to do base conversion. It would have helped you. And then plus and minus, of course, makes sense. And there's a concept of like negative numbers. It's all there. It's all possible. Any questions about any of that? So that's Python in a nutshell. And then you can put 2 stars for to the power of. It's not the caret character. It's not like 2 to the power 3 like that. It's 2 star 3. That gives you 2 to the power 3. So don't do this. It does something else. We don't like that one. Not yet. So yeah, this is technically valid lines of Python code. Math. It's happy. And you can add parentheses and do fancier things. But that's a start. Are there any questions about that? That's technically our first lines of Python. Not too horrible, I hope. So that's just using Python as a calculator. But it's got more going on under the hood. And to get there, we need to talk about the types of things, which I just touched on very slightly in Scratch because it didn't really matter. But now it matters. All right. So there are different types of values in Python. And you can ask Python for the type of what you just gave it. You can say type, put some parentheses, and then fill in the blank with what you want to know the type of if you forgot. Like, well, Python, hey, what is the type of 42? Oh, that's an int. What's the type of, int is short for integer. What's the type of 3.14? Oh, that has a decimal, so it's a different type. It's a float type. It stands for floating point. It's a decimal kind of number. So different types store different things, right? And I'd like to teach types as like a cloud where you can only like have certain things. So the int type, what are the things that live in the int cloud? Those are whole numbers, integers, all right? 0, 1, 42. Could be negative though. Negative 42 is fine. So things that are of the int type are whole numbers only. The second you start adding decimal places, those things live in the float type, and they act differently because now you have decimals. Float. The float cloud, it has like 3.14. It has negative numbers as well, of course, but with decimals, negative 23.145, blah, blah, blah. It also has whole numbers, but you think of it as like 20.0. You could have decimals if you wanted them. For ints, you cannot. All right, that's an important thing. There is also, when you want to print words out to Python, the type of that is str, stands for string. It holds a bunch of characters. So, interesting. That is things between double quotes or single quotes, like, hi mom, that is a string. It evaluates to itself, but what's the type of hi mom? It's str. String is short for like string of characters, like on a friendship bracelet or something. That's how you think of it, but that's what it means to be a string. It's just a bunch of characters at once, all right? And so you can say anything between quotes is a str. Hello. And Python doesn't care about double quotes versus single quotes. You can just say hello with double quotes or hello with single quotes. It doesn't care. It's happy. But now I can show you the reason we care about types. Plus and star work for strings too. Watch. Like, I don't know, ABC. I can add that to the str def with the plus. Python knows how to plus on strs. And that just puts them together. That makes a bigger str that holds all those characters at once. That's kind of interesting. And then you can also multiply a string by an int. You can be like, hi times 7. And that repeats that str a bunch of times. You see that? So that's interesting. Notice how that's completely different from multiplying like an int, 3 times 7 by an int. Python knows the difference because it can see the types. That's very important. All right? That's what's going on. Like str times an int works completely differently from int times an int. Same with plus. Does that concept make sense? The fact that we're using different types with this operator cause it to work differently and give back different things. This is all maybe a little weird. How are we doing? Any questions, comments about any of that? So types matter now. We have to care about them. Okay? So, all right, multiplying a str by a number gives you that thing repeated a bunch of times. Here's this idea. Whee! So I'll give you all this, and then I have a question for you. Dun. Here's all this right here. Just for a second. I'd like you to try something now. I'd like you to create the string hello space hello space hello space hello space hello, no space at the end. Okay? So no space right here. No space. I want 42 hellos. See if you can make that string. But separated with a space. Do not include a space after that last hello. How can you do it? Can you figure it out? I'll give you a few minutes to try. You don't have to write it down anywhere. See if you can help each other and figure out the secret. How do you know how to repeat stuff, but what do you got to do if the last thing can't have a space after it? How would you fix that? All the tools are in that screenshot. The answer is secretly there somewhere. You just have to combine some stuff. might be easier to just try to get like hello 5 times, so you can actually count how many hellos there was without a space at the end. Then that would generalize. All right, that is my timer. Did we figure it out? Did we notice the secret? So let's say I wanted 3 hellos separated by spaces. Let's say I wanted this string. Hello, space, hello, space, hello. I could get very close by just saying, I don't know, I'll use single quotes this time. Hello, space, times 3, but that messes it up, right? That puts a space at the end because it repeated hello, space 3 times. That's not what I wanted. I wanted no space at the end. So how could I fix this? I could do hello, space, times 1 less. That will get me hello, space twice, or 41 times. And then I can worry about that last one separately. That's the secret. Let me change this. Is that what we figured out? Yeah. Still very subtle, though, once you're first learning it. So this is repeatable, this part. But the last part, it kind of exists on its own. There's no way to, like, remove stuff. Or I haven't taught you how. That's the idea. So it's, like, separated into this string, build this one, and then add it to this one. Okay? That's going to be the answer. So hello times 41, or times 2 plus another hello, without anything. No space at the end there. See that? So you can do larger things. And it respects the order of operations like it does the multiplication first. It's not going to mess it up. But you could put parentheses if you wanted to. But that's how you would do this. Like put 41 hello spaces, but then the last one is hello just by itself. No space. And so that'll enforce the fact that there is no space after that O there. Okay? Any questions about that? Does that make enough sense? That was your first programming problem in Python. All right, so let's get fancier. We know a lot of things in Scratch. Let's try and recreate them in Python. Let's figure out how to do just to print things out to the screen. The REPL's doing it automatically for us, but this is not a Python program yet. Let me just say that right now. This is not Python a program. This is just us interacting with the REPL. It's very different, all right? We'll get to that in a second. And so it's just automatically printing things. How do we programmatically print things? And then how do we make a variable? How do we work with that? And then how do we ask the user for stuff? That was some of the things that we did on the first day of Scratch. So we should do that today too. So we need to move beyond the REPL. The REPL is just for quick math or something. We want to write a real Python program, all right? And a Python program is its own little file, all right? You're going to make a file called like program, whatever you want to call it, program. And the standard extension for Python programs is .py. So you're going to make a .py program, and then in that file, you're going to put a bunch of lines of Python code that you want to run in order. All right? Lines of Python code are called statements. That's another word for that. And they're going to run after each other, just like in Scratch, but it'll be text-based. All right? So let me teach you how to make a Python program, so a file this time, that prints hello world to the screen, because like that's the standard thing that you got to learn first. Your first program in every language has to be a hello world program. It prints out hello world to the screen, and there is this thing called the print function in Python that will give us access to that. So first, let's make a new file. Let's make a new file, and I'll make it in a special place. You can make yours wherever you want, but I got to give this to you, and this is lecture 13 apparently. So we'll do it this way, but you have to follow this process too. So this is idle, this is the REPL. To make a new Python program, you go to File, New File. File, New File. Click that, and then you are in a blank file that is Python. Will eventually be Python code. All right, it's called untitled right now, so give it a name by just saving it. You can go to File Save, Control S, or Save As, whatever. It's not saved right now, so it'll figure out and ask you where you want it to go. It's trying to save it in the place it was installed, which is a horrible idea to save a Python program. So, like, go to your downloads folder or go to your desktop, save it somewhere. I don't know, somewhere normal. And I'm going to save it in our code from class folder. make a folder for today, lecture 13. And I'm going to call it, you can just give it the name and it'll add the .py itself. I'm going to call it, I guess, maybe hello? No, I'll call it hello world. And I'll add the .py. You see the type is already set. So when I click save, it is saved hello world.py somewhere. This place for me, different place for you, I'm sure. And so now I have a blank Python file that I will fill with code. All right, it'll eventually run. Have we all been able to get a blank file for ourselves? So this is a Python program now. This is a honest to goodness Python program that we will add to. All right. So we are going to make a hello world program, and it's going to be one line to print hello world. It's very simple. The way it works is we're going to call this thing called the print function. All right, so some stuff that's been implemented for us by the Python people, it's called functions, and we can what's called call the functions. All right, so the way that you call a function looks like this in general. You say its name, and then you give it a bunch of things between parentheses that it wants, comma separated. More examples will make this make a lot of sense, I promise. Those are called arguments, and then sometimes you save the answer somewhere if it gives back an answer. So we will get to all of that later, but right now all we need to do is call the print function on a line by itself, just say print, and then between the parentheses, we give what we want printed. That's the argument that you give it. So print is the name of the function that we want to use right now. And then we're going to say hello world, but I ran out of room on the slide. So you give it one argument, we say. One argument. That's the one thing we want printed right now. One argument to the print function. And it knows how to print to the screen. All right, so I'm going to go back to my empty file, and I'm going to say print, and then I'm going to give it the string that I want printed between parentheses. Print hello, comma space, world, exclamation point. And then if I save the file, file S, or Control S, file save, now I can run it. I can run this program, and Python's gonna go through every line, every statement, and run it one by one. We just have one statement though, so it's very simple. But to run your program that you just wrote, and all the lines in it, if there are multiple, you go to the Run menu, and you say Run Module, or you just hit F5. And then it runs it right here. It says like, all right, I'm starting it, and then here it gives you all of its output before it gives you a new REPL prompt. So here was the output from our program just now. It said hello world, and it printed it to the screen. How fun. Any questions about any of that? So that was a very simple program, but this is our first real Python program. It's in a file all by itself. Yeah. Oh yeah, to run it, it was this Run menu. Run module. And it will force you to save it if you didn't save it already. And then it runs it from start to finish, all the lines in the file, and it does what you said to do. So you can add multiple print lines, and it'll print everything you say, one by one. So yeah, how fun, how interesting. We also have comments in Scratch. That's very helpful for us, right? Comments exist so that we can, as programmers, leave ourselves little notes for later. Comments exist in Python too. They look like this. You can make single line comments with a number sign. Where was I going with this? You can make single line comments with a number sign, then everything after the number sign is marked as a comment, and it's not interpreted as code. You can also make multi-line comments so that you don't have to put a number sign at the start of every line with a button, and you put it like 3 triple quotes. You wrap your giant comment that's multiple lines around 3 triple quotes. So, or 3 single quotes, sorry. 1 triple quote, I guess. And so let's see here. Let me write some comments. And you'll see that the idle is very nice, and it highlights it in a way that you know it's a comment too. Super nice. So this is a comment. See how it's red? It's not Python code. I started this line with a number sign. It's not Python code. It's just for me. It's just a note. Everything after the number sign is a comment. Python's not going to pretend to run it or anything. It's not going to try. It's like, all right, that was just a note for the programmer. And you can put comments on lines with code before it. It's just everything after the number sign is marked as a comment. Be like, let's leave ourselves a note. What does this line do? Oh, it prints hello world. Something like that. So this is still code. It's just the second you put a number sign, everything after that is interpreted as a comment, right? So that's a single line comment. And then multi-line comments begin and end with triple quotes. You can use 3 double quotes as well, but I'll use 3 single quotes. This is it's essentially just a fancy string, honestly. Multi-line, blah, 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 comment, and you can make the spacing as weird as you want. You just got to close it off with 3 triple quotes, and then you can put more code down here. But if you don't want to type a number sign all the time, this is a multi-line comment, all right? But still, the only real code in this file is this print statement. So if I run it, nothing has changed. Still happy. Everything else is just a note for us, right? Any questions about that? So that's how you make comments in Python. Let's see here. All right. So if we are happy with that, let's move on. Let's make variables now. Variables and assignment. All right. So you can make any variables you want in Python. They're able to hold whatever you want. But variable names in Python have to follow a pattern. You cannot have spaces in your variable names. That's why I took care to not put any spaces in Scratch variable names, even though technically it's allowed there. Trying to get you ready for Python. So variable names can't have spaces or special characters like exclamation point or a number sign or something like that. Because you know that one's special already. So variables, the names of variables in Python have to start with an underscore or some alphabetic character. Doesn't matter if it's capital or lowercase. And then after that, you can also start using digits. So you cannot start a variable with a number, but it can be somewhere in the variable after the first character, right? So valid variable names in Python would be like x, underscore, underscore x, underscore, 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 blah, 42. As long as the first character is an underscore or an alphabetic character, it's happy. But you can't make a variable called 42 blah. That would not work because it starts with a digit and then it's not allowed, right? So you have to pay attention to that at the start. Just get used to what kinds of variables you can make. And then once you've decided on a name for a variable, here's how you give it a value. You can also create it if you've never mentioned it before. Use an assignment statement to both create a variable and give it a value initially, or to change it if it's already existing. What you do is you say its name, you say variable name, whatever you came up with, and then you say equals, and then you put some giant thing over here potentially that eventually becomes a value, some int, some stir, some float, or whatever. And what Python is going to do is it's going to run the code here on the right side, get that value, and shove it into the variable. That's how that works. So a very simple line would look something like this. X equals 42. That would create a variable x and have it hold 42. Though it could be extra complicated now. Watch what I can do. Because the right side happens first, it figures out that value before it shoves it into the variable. After this line, I could also write this line. I could say x equals x plus 1. What do you think that does? I think this is even allowed. So because this side gets executed first, it's happy. It's like, all right, what's x plus 1? Oh, it's 42 plus 1, so 43. I will just place 43 into x now, and it will change x from 42 to 43. Makes it one more than what it was before. Weird. So the right-hand side of that assignment gets evaluated first, gets executed first, and that makes it so that it's not a problem. Okay? It's very weird, but that's how that works. So let me make a file for that shows all this. I'm going to go File, New again. File, New File. Oh, actually, what I should do is I'll go from here, and it will save in the same place, I think. File, New File, save it, and I'll call this vars.py. But you can just keep typing on your current file, whatever you want to do. I'm just trying to give you everything separate. So I will make a variable, x equals 42. That's an assignment statement. And now x exists. It's a box that holds 42, and I can say, instead of typing 42, which is maybe too long, I can say, hey, Python, print to me the value of x right now. And it'll just go and look it up. It's like, all right, yeah, x is 42. If I run this, run module, it's like, yeah, there's your 42. That was what was in x. Does that make sense? And then you can be like, all right, x equals x plus 1. Make it bigger. What's x now? Print x now. See how it's going from top to bottom. It's executing in order still. It's like, all right, it was 42. That was the first print call. And then when we called print again, we said, all right, give it x, tell me what x is now. Print me the current value. Well, it got changed to 43. So we're going to see the line 43 after that. So that's the new output. Any questions about that? That's a fun little idea, I think. All right, if we're happy with variables, now we have a place to put input. So let's go and get input from the user. So in Python, it's just there's a function for everything. So instead of print, we're going to call the input function. All right, and what happens is the input function takes an argument. So going back to this slide now that you understand it more. To call a function, you say its name, and around parentheses you put comma separated arguments, whatever it needs to do its thing. Print just took one argument, what we wanted printed, but some functions take multiple things. And then sometimes the function gives a value back. Print just goes off and does something for us. So we don't need to get a value back from print. That makes no sense. But input, when we call the input function, it will give us back what it got from the user. And we can go and save that in a variable. So this is a very standard line that you'd see a lot in Python. It's just call the function and save the result immediately into a variable. Okay? That's how that's going to work. So, yeah. In Python, we're going to call the input function. And the input function also takes an argument. You give it a string, and it will display this string as it's asking the user to type something. So that's where you put your little prompt. It's like, input, enter your name. We'll have it say hello to us or something. Enter your name as a string, colon space, so that it's all nice and pretty. And so the second we call this, it will stop the program, print this out, ask the user, hey, enter your name, and it will wait for keyboard input. And then the second the user presses enter, it will get the value back and give it back, right? It gives back that result. That is the user's response, right? And so we can go and save that result into a brand new variable, maybe. Call it resp or whatever you want to call it. And let's see. What it's going to do is it's going to give you back a string. So, for example, if we correctly entered our name, after we run this line, it will set ask us for our name, get it back, and then put the answer in the resp variable. So if I typed my name, for example, the resp variable will be created, and it will store the string that is my name. And it will be just sitting there. All right? It's very important, though, if you use input, every time you use input, it gives you back the thing that the user typed as a stir. As a stir. All right? Even if the user typed digits. You're assigning the result of input to like a number variable. If the user typed 42, it's going to give it to you as the string 42. All right? And what's the problem with that? You cannot do math with the string 42. You remember this? Like the string 42 times 2, that is sure as heck not 84, right? It's a stir still. It's just characters. It doesn't know that it's numbered unless you convert it. All right? So I'll show you how to convert your input to a number by just calling the type that you want it to be converted to as a function. Right? So there's a lot to unpack there. But remember that input always gives you back a stir, even if the user's typing digits to you. So let's, how do I want to do this? Let's do it this way. So let's make a program that does ask the user for their name. And we'll just say, hello, your name. So I'll make a new file. I'll call it gettinginputs.py. Got too many windows open now. But the idea is I'm going to do exactly what I wrote here. Getting inputs. So, all right. Response, that variable equals the result of calling input. And you call input with the prompt you want to show the user as it's getting that input. So enter your name. And then colon and a space will be nice and pretty. I'll show you that. And then we'll be like, all right, we get it back and we can say, hello, your name. Now, we say, hi, comma, space, plus resp, because that holds the name, and then plus like an exclamation point or something. So that would be a cute little program that like gets the name from the user, puts it in the resp variable, and then prints out, hi, comma, space, your name, plus exclamation point. You see, I'm using that variable. Whatever the user typed, it's going to be in there. So I can print it back out. So run it, enter your name, Lawton, and it says, hi, Lawton. And, of course, whatever you type, it'll save that in the variable. Any questions about that? So here, when you call input, it pauses the program right here, and it asks you to type as the user. And then once you hit enter, it gives it back to the input function. And it lets the program continue. Any questions about that for now? Because I do want to just highlight the fact that whatever you're getting back from the input function is a stir. All right, we just got resp back. What is the type? Print the type of resp, please. Enter your name, Lawton. It is a stir. It is a string no matter what. All right. So even if we ask the user, hey, num equals the result of calling input on enter your favorite number, no matter what, input is always giving us back. Print the type of num. It's always giving us back a stir. And so it's not really going to work right if we do like something like print num times 2. Watch. So enter your name, Lawton, enter your favorite number, 42. It got it. Input's always getting it as a stir. So that was its type. Print its type of that num, even though it's the characters 4 and 2. It's still a string. And so when we multiply a string by a number, it just doubles the string. 4242, not the 84 that we really wanted. Do we see that that is potentially a problem that we'll have to watch out for one day? All right, so the way to fix this, the way to get it to be a number, if the user really did type a number to you, you can convert what you got. You can convert a string to a number by calling the type you want to convert it to as a function. Just say int of that thing, float of that thing, if it had decimals. All right, so let's put it into another variable. We can say this, int num. That's what we really want. We don't want to like mess with num before it's an int. So int num will convert it, and then we can put it somewhere else, like num as int. We can make a new variable, have it hold the integer version of num. All right, so num is only a stir. We must convert it to an int to do math. All right, so that's the idea there. Boop. And so now I can use the num as int variable because that got the correct converted value. Multiply that by 2, print it out. Now it's going to be happy when I run it. Wow, so it was a stir back here, but the second I converted it, I put it in this variable, put the converted thing. Now it's an int, and so multiplying that by 2 is in fact 84. All right? Any questions about that? That's how you convert things. Convert from a stir to an int, or a stir to a float if the user is going to type maybe a decimal number. Let's see what else. So functions can take multiple arguments, and you separate those with commas if you need to. We've just been using input, it took one thing. Print can take one thing too. But print could be fancier. Print has the ability to take an arbitrary number of arguments. And what it does is it prints out the first argument plus a space, plus the second argument, plus a space. It just space separates the things that you give it. And so instead of what we did up here, print hi, comma, space, plus resp, plus exclamation point, we could have done it like this. Print hi, comma, and then comma. Oh, sorry, single quote. Then comma, and then the response, then comma, exclamation point. And so it's just like print this, then this, then this. That's what it means to give it multiple arguments like that. So print can take as many args as you want. What it does is it space separates them as it outputs. And so watch what happens. It's not quite what we wanted, but it's close enough for most things. So here was that line, that new line. It's like it separated the high comma with a space, and then it put my name, and then it separated my name and an exclamation point with a space. So if you're like outputting French, this would be correct, but not quite for English. We don't want a space before exclamation points. So when you want that fine grained control, then you do really have to start adding strings together. But a lot of the time, the comma works out. That is, that's as much of printing as I think I want to show you today. Are there any questions about any of that? Before we get to the last topic for the day. So now I want to talk to you about, well, computers were invented to do math. So let me teach you this thing in Python that has a lot of predefined math functions. It's called the math library in Python. So a library in a programming language in general It's just a bunch of stuff that somebody else wrote for you. Right? It's a bunch of pre-written code. How nice. That does a certain thing. Pre-written code that you can use as many times as you want inside of your programs. Inside your programs. And there are a bunch of different libraries, and Python doesn't just want to like assume what you want to use, and so you have to import the math library when you want to use it. That's the technical term. But there is a very nice documentation page on the python.org website that talks about the math library and tells you all of what's in it. And the easiest way to just get there and see it is to say, just say Python math, give that to Google. And like the very first link, it's going to be the Python documentation page on the math library. So here is everything that exists in the math library in Python. All the mathematical functions. There is absolute value, exponentiation, greatest common divisor. All these things have been written by somebody else for us to use. What else we got? Useful stuff. E to the something. Functions, logarithm functions, do a power function, trig stuff, so inverse tangent, sine, cosine, all that stuff. It's in the math library. It also defines some special math variables, too. It doesn't have to just have functions in a library. They make some variables for you, too, like you have pi, e defined, they're all there. So yeah, that's the math library, and let's use some of the stuff there. We'll consult the documentation to use it, though. So let's see here. I'll make a new file, I guess. And so to use the math library, you have to import it in Python. So the very first line of your file is going to be usually an import statement saying what library I want to use for this file. So before you start using math library stuff, you have to import it. So usually that's going to be the first line of your program. So import math is what you say, to import that library. And then after that, you can start using math library stuff. So this line, the import math line, makes math library functions available for you to use. It opens the book in the library, I guess. Available to use. And because some libraries there might be a competing math library called Math version 2 or something, I don't know. To specify which version of things you want, you always say the name of the library and then you put a dot and you say what inside of it you would like. So you don't just say pi, you don't just say square root, you don't just say sine, you say math.sine, math.pi, math.square root, right? It's always the name of the library you're importing, dot the thing inside that you want to use. It's like a separator. Thing inside library. So if I want to call the square root function on something, I have to say math.square root of 2 or something. Like that. You always have to say its name. There's a way to get rid of the math dot, but I'd rather you just learn it this way to start. But let's make a program that uses the math library. I'll make a new file. New file. And in Python, all a library is a special file somewhere called math.py. And you're importing that. So a very common error that you will do one day, just watch out for it. It will ruin your day. Never make a file, never save a Python file with the same name as a library. Because then it will try and use your file as the library. And you were trying to use those functions, and it's just not going to work. All right? It's going to lose access to the library the second you make a file with the same name. So don't make a file called math.py. Never do that. Okay? Now you know. So what will I call this? I won't call it math.py. I'll call it mathstuff.py. How about that? That'll work. And so to get access to the math library functions that I'd like to use, I say import math. That works. And so now, after this line, now we're allowed to use whatever we want. Now we're allowed to use all the math library functions. Yay. and other things that live there. So there's also special variables defined as well, just like pi. Math.pi exists. So, I don't know. As our first example, let's make, I don't know, let's do some math. Let's calculate the area of a circle. Why not? So let's calculate the area of a circle with radius. Let's say the radius is 4.5 or something. All right. So we want to calculate pi r squared, right? So we want to do something like pi times the radius squared as pseudo Python code. So let's separate all this stuff into variables. So I got a radius. I'm assuming it's 4.5. Let's shove that into a variable. I've got, I want to calculate the area based on that radius now. So the area, I will save into a variable called area. And the answer is, the way to make the area is use the pi variable defined in the math library, so math.pi, and multiply that by the radius squared. So radius lives in the radius variable. That's where I just put it. And it's 2 stars for the to the power of. So this is pi r squared. That works out. And then now that the answer has been evaluated and placed into the area variable, so I can say print area. And it's happy. So if I run this, whatever 4.5 times pi squared is will appear in the output, and it is apparently this. So that would be the area of that circle with radius 4.5. Here I am using a variable defined in the math library. Any questions about that? So it's math.pi. That's the piece of the math library I'm trying to use right now. It wasn't a function, it was just a little variable that lived there. Where did they talk about it? It's like way down here. It's a constant defined in the math library, math.pi. Next, let's use the square root function. So where's that? Math.square root, you give it one argument and it returns the square root of that thing. Back the square root of that thing. So let's, I don't know, let's ask the user for a number, and then we'll just make the square root of that. We'll give back the square root of that. So let's calculate the square root, SQRT in Python land, of a number that the user types. Cool. So let's get a number from the user. The number is whatever the input function gives us back. So ask the user, call the input function, enter a number, colon space as the prompt, and then the input function will go off, pause the program, ask the user to type. They hit enter, and then it gives back the answer, which we will then place into the num variable, right? And the user might want the square root of like the number 42. They might also want the square root of the number 42.5. And so what is the type that I should be converting num to? Because right now it's just a str. What type should I convert it to if it might have a decimal in it? Do you remember its name? Which are the two options? Int or float? Float, yeah. So int is whole numbers. That's the int cloud. Numbers with decimal places, that lives in the float. The float type. So if we might have a decimal place, we need to convert to the float type. If it didn't have a decimal place, that's fine. We'll just save it as 42.0. But we need the ability to have dots, to have decimal places. So I will convert num to a float by calling the type I want it to be as a function, giving it the variable that's a str right now. And then I can save that as like num as float. There, that'll work out. And then I wanted to generate the square root of that number, so I will print out the result of calling math.square root. So I'm chaining these, that's kind of interesting. Num as float. All right, so Python's always going to work its way in to out, inside to outside. So it's like, I need you, Python, to print this, and it's like, okay, I don't know what that is yet. I don't have a value to print, but I'll go off and I'll run this function. I'll call square root on this variable, and then I'll get an answer back from that, and then I'll print whatever that was. That's what it's doing. It's going to go on the inside first, do this, figure out what that answer is, and then print it. It's going to kind of get replaced with the answer that it gives back. I hope that makes enough sense. So here we go. Enter a number, I don't know, 2. It converts it to 2.0, the float 2.0, and it gives me the square root of that. Or it's like 2.5. That is apparently the square root of 2.5. Any questions about that? So we had to convert it to a float. It was just a string. Square root would not have worked. Actually, let me show you an error message. Let me accidentally, instead of saying square root of num as float, say square root of num. Enter number, 42. This is an error message in Python. It's like, you were calling this. There was a type error. Must be some sort of number, not a stir. It's trying to be helpful. So that was the problem. Num as float. That's going to work. Okay. So, hope that makes enough sense. We good with that? So that's another function in the math library. Let's use the sign function. That's a very common math thing to do, to want to use. So let's do that. Let's call the sign function on this value on this number that the user typed to us. All right. So let's print. Let's save the result in a variable first. Let's call math.sign on that number, num as float. And then let's save that answer. It's going to give it back to us as like a variable. We'll call it sign of num, I guess. That'll be its name. And let's print out that sign in a pretty way. We'll say print the sign of, and then let me use multiple arguments to print so that so that space separates things for us. Use commas to separate arguments. So the first thing we want to print out on the line is the sign of, and then a space, and then I want to print the number, num as float, so the sign of that. Then I'll say is, and it'll wrap everything around with spaces, and then I'll say sign of num. So that's an easy way to print everything that we want printed out. It'll add the spaces for us. And our number, 42, apparently the sign of 42 is this. And you see how it's going to print it out on a very pretty looking line. Like, print all these things in that order. What's a normal thing to take the sign of? I don't know, 3.14. Sign of pi is pretty much 0, but I did not give exactly pi, right? To 2 decimal places, it's 0 at least. So that's me calling sign, math.sign function. Any questions about that? All right, so I'll give you this program to look at, but I have a question for you now. I'll take this as a screenshot, though, so that you can see it. But here's what I want you to try. Write a program. Here's this. Write a program that takes 2 numbers from the user. So ask for 2 things this time, 2 input calls. Call them A and B, and have it compute the square root of a squared plus b squared. So maybe, I don't know, for example, this is supposed to be like maybe a right triangle problem. So maybe the user typed A as 3 and B as 4, and then you'd go and calculate this. That would be the length of the hypotenuse of that triangle. It would be 5. Yeah. So see if you can get 2 numbers from the user, put them into variables, and then output the result of the square root of a squared plus b squared. It's like a right triangle hypotenuse solving problem. I'll give you a few minutes to try that. Help each other. So you have to get input twice this time. Take them into different variables. And those are going to be numbers again. Maybe you want to use float, maybe you want to use int. I don't know. What do you expect the user to type to you? If there could maybe be decimals in that number, better be float. And then where was square root? You're going to need square root. Square root, and then here was the to the power of operation. So all those pieces. That should do it. another minute or so, and then I'll show you my answer. All right. Were there any questions that came up as we were trying this? Get it? So you try the 3-4, have it C5 as the output? All right, let's try it. Let's see, how will I do this? I will make a new file. It always makes the window so large. And then I'll save it as, I don't know, hypotenuse.py. That's what it's solving for, really. So I want to use square root, which is defined in the math library. So I better import math. Now I can use math.square root. And then I need two numbers from the user, A and B. So like input, enter A, colon space, and then input, enter B. I can use single quotes if I want to. Give me two numbers, user. And then I need to save these somewhere. But I need to save them as floats. Because maybe the user's going to ask, like, the left side of the triangle is 3.5 or something. So this, I want to convert it to a float. And I can do that before I put it in a variable, actually. I can just say, hey, float. Create a float out of whatever input gives me back. That's much quicker. Create a float out of whatever input gives me back. See that? So run this first, get it back, and then call float on it. It's kind of cool. It works its way from inside to outside. And then that's really what A is. It is a float now. That's really what B is. Perfect. See how that's working? That's pretty nice. And then, why is that there? I don't know. Too many spaces. Now I can calculate the hypotenuse. What is the hypotenuse? It is the square root of a squared plus b squared. So first I got to do a squared plus b squared. That's a squared star star 2, a star 2 plus b star 2. And then I want to take the square root of that. So it's math dots sqrt, all those things. And that will compute the right answer, store it in the hypotenuse variable that I can then go and print out. All right, so that would be my program. The cleanest I can write it, I think. Any questions about that? Let's have it try 3, 4, 5 triangle. A is 3, B is 4, 8 is 5. Nice. And then what's the other one? It's like 45, 45, 90 would be square root of 2. So like if both sides were 1, then it would be square root of 2 as the hypotenuse. So that seems to be working. But it could be anything. You could type in whatever you want for A and B. Any questions about any of that? Is that making sense? It's a good example of the math library. So if we're happy with that, let me show you a very, very special place. It's a website. It's going to save your life one day. So you can go to this link, or you can just search for Python tutor on the internet. It is pythontutor.com, though. Say Python tutor. It should be the first link, unless there's a bunch of like ads on Google. But Python tutor is what you want to click. And what it will do is start coding now in Python. And here it will give you a place to put your code. If you're not sure if like something's not working right and you're not sure, it's giving you back the wrong answer, this is the best place ever. Let me show you. So let's use a very simple program. Let's go back to like vars or something. This program. If you just copy and paste your program here, the one thing that this won't do, by the way, the one thing Python Tutor can't do is get input. It's going to show you how your program works line by line, but it can't get input. So you have to like hard code the answer. Don't get rid of any input calls. Just put values and variables. So this one's going to work just fine, but you'd have to remove any calls to input. And watch what this is going to do. If this was giving me the wrong answer and I didn't know why, watch how beautiful this website is. You click Visualize Execution, and then here's your program on the left, here's the output screen on the right, and then down here is going to show you every value of every variable, and it will change. All right? So, all right, we're starting the program. This is the line that's about to run, the red line, x equals 42. I can just click Next. It's going to draw exactly what's going on line by line in this program. Do you see how that will save your life one day? Tell you exactly how it's executing when you can't figure out what's going wrong. So, all right, print x. All right, x is this variable. It holds 42. Next. This is the output screen right here. So you saw that 42 just got printed. And then it's like x equals x plus 1. That's the next line to run. Click Next. It will run it. And you see, watch this variable change to 43. If you were confused why it was printing 43, now you know. You saw that value change right before this line. Print x. Next. You see the 43 in the output. Sorry, it's so small, but this will one day save your life, I promise. It will tell you what was going wrong with your program. You can watch it work too. So powerful. Greatest thing ever. Any questions about that? I encourage you to bookmark this page. All right. If you're happy, there is not too many minutes left of class, so let's see what we got left. I don't have any new assignments for you, so I guess the last thing, if there was time, I guess there is if you want to stick around, but you can do this at home too. But I highly encourage you now. I'm going to give you all this code. Look at it. Try to write your own program that does something cool. Ask the user for some input, calculate some cool idea, or just practice doing stuff on the REPL. Practice what you learned, because that is going to make you good at Python. All right? But that is all that I have for us today. That is our first taste of Python. I hope it was nice.